Welcome to our channel. Today we're embarking on a journey that will take us beyond the familiar confines of our earthly existence and into the vast, enigmatic expanse of the cosmos. We're going to explore, question, and unravel some of the most intriguing phenomena that the universe has to offer. One such phenomenon is the concept of mass, a term we often use but rarely pause to fully understand. How does it work here on Earth? And more importantly, how does it behave in the seemingly weightless environment of space? By the end of this video, we hope to provide you with a clearer understanding of this fundamental aspect of our universe. So buckle up, sit back, and prepare to have your mind expanded as we dive into the enigma of mass and space. Let's set the stage for a journey of discovery, one that will take us from the smallest particles to the largest galaxies. Have you ever wondered how mass works in the vast expanse of space? Today we're going to delve into that captivating enigma. When we think about mass, we're essentially talking about the amount of matter that an object contains. It's a concept that seems pretty straightforward when we're grounded on Earth, where the pull of gravity gives weight to our physical existence. But when we venture into the cosmos, things start to get a little more complex. In the weightless realm of space, the concept of mass becomes a bit of a brain teaser. It's not about how heavy something is, but rather about how much matter it contains. And that's where the real intrigue begins. Mass in space isn't just about understanding the physical world around us. It also holds the key to unlocking some of the greatest mysteries of our universe. Understanding mass in space can help us grasp the fundamental laws of physics. And that's a journey worth embarking on. Before we unravel the concept of mass, let's take a brief detour to understand the interplay between mass and gravity. You may ask, why gravity? Well, it's because gravity and mass are two sides of the same coin. In the cosmos, mass influences the space around it, creating a curve or a dent. This is what we perceive as gravity. Think of it like a bowling ball placed on a trampoline. The ball represents a massive object like a planet, and the trampoline is the fabric of space. The ball causes the trampoline to dip or curve, creating a gravitational pull. Now, if we roll a smaller ball, representing a less massive object, it will roll towards the bowling ball, drawn by the curve. This is a simplified way of explaining how gravity works in space. In essence, gravity is the result of mass's interaction with the fabric of space. It's not just a force pulling things downwards as we often perceive it on Earth. It's a complex relationship between mass and space that shapes the universe as we know it. Understanding this relationship is crucial to grasping the concept of mass in space. So as we journey forward, remember, mass and gravity are intrinsically linked, each shaping and influencing the other in the cosmic dance of the universe. To comprehend mass in space, we need to first understand what mass is. On the most basic level, mass is a physical quantity that quantifies the amount of matter in an object. You can think of it as the total amount of stuff that makes up an object. Whether it's a tiny pebble, a human being, or a colossal planet, each has a certain amount of matter, and thus, a certain mass. But here's where things can get a little tricky. Many of us often confuse mass with weight. However, they are not the same. While mass is the amount of matter an object has, weight is the force exerted on that mass due to gravity. Weight can change depending on where you are in the universe. For example, if you were to stand on the moon, which has about 1/6 the gravity of Earth, you would weigh less than you do here. But your mass, the amount of stuff you're made of, would remain the same. That's right. Mass is a constant. It remains the same regardless of where you are in the universe. Whether you're standing on the surface of the Earth, floating in the International Space Station, or drifting through the far reaches of space, your mass remains unchanged. It is an intrinsic property of matter that isn't affected by external factors such as gravity or location. So, in a nutshell, mass is a measure of the amount of matter in an object, and it's different from weight, which is the force of gravity acting on that mass. And crucially, mass is a constant property that doesn't change, whether you're on Earth or in the vast emptiness of space. Now that we understand what mass is, we can delve deeper into its role in space. In the previous scene, we learned about the fascinating concept of mass and its constant nature. Now it's time to delve into the relationship between mass and gravity, a bond that governs the cosmic dance in the universe. Imagine a universe without mass. It would be a barren, static expanse of nothingness. There would be no stars, no planets, no galaxies. Why? Because mass is the cornerstone of gravity, the force that brings matter together and shapes the cosmos. When two objects in space have mass, they are attracted to each other. This is the force of gravity at work. The more massive an object is, the stronger its gravitational pull. This gravitational attraction is what holds our universe together, from the smallest particles to the largest galaxies. But it's not just about attraction. Gravity also influences the movement of objects in space. The planets in our solar system, for instance, orbit the sun because of its massive gravitational pull. Without this pull, Earth and the other planets would simply drift away into the cold, dark void of space. So, gravity, driven by mass, is the tether that binds the universe together. It's the unseen puppeteer that controls the cosmic ballet, dictating how celestial bodies move and interact. In the next scene, we will explore the dynamics of mass in space, delving deeper into the intriguing dance of celestial bodies under the influence of gravity. Stay tuned. In space, mass takes on a whole new dimension. The cosmos, vast and mysterious, is not just a vacuum filled with stars and planets. It's a stage where the dance of mass and gravity unfolds, shaping the universe as we perceive it. Now you might be wondering, how is mass in space related to gravity? Well, remember that mass is a measure of the amount of matter in an object. In the cosmos, this matter exerts a gravitational pull on other objects around it. This pull, or force, is proportional to the mass of the object. The more mass an object has, the greater its gravitational pull. This leads us to the concept of gravitational mass. It's a bit of a mind-bender, but stick with me. Gravitational mass is essentially the amount of force an object can exert due to gravity. It's the reason why an apple falls from a tree and why the Earth orbits the Sun. The Sun, with its hefty gravitational mass, pulls the Earth and other planets towards it, keeping them in their orbits. But mass does more than just pull objects together. It also plays a pivotal role in the formation of celestial bodies. Picture a vast swirling cloud of gas and dust in space. Over time, the particles within this cloud begin to clump together due to their mutual gravitational attraction. These clumps gradually grow larger and denser, forming protoplanetary disks, asteroids, planets, and stars. Without mass and its gravitational pull, this cosmic ballet of creation would simply not be possible. Here's something to ponder. The stars we gaze at in the night sky, the planets we dream of exploring, and even the cosmic dust that floats through the vast expanse of space, all owe their existence to the intricate interplay of mass and gravity. Mass in space, therefore, plays a significant role in shaping the universe as we know it. In our journey through the cosmos, we've often encountered mysteries that challenge our understanding of the universe. One such enigma is the concept of dark matter. While we have understood how visible mass shapes the universe, there exists an unseen force, a hidden mass that seems to hold galaxies together. This invisible yet influential player in our cosmic theater is what scientists refer to as dark matter. Despite its name, dark matter is not dark or shadowy in a conventional sense. Rather, it is called dark because it does not interact with electromagnetic radiation like light, making it incredibly difficult to detect. However, we can observe its effects through its gravitational influence on visible matter. It's like perceiving the presence of an unseen artist through the strokes on a canvas. Scientists estimate that dark matter makes up about 85% of the universe's total mass, shaping the large-scale structure of the cosmos. Its gravitational pull influences the motion of galaxies, and even bends the path of light traveling through space, a phenomenon known as gravitational lensing. Yet, despite its omnipresence, dark matter remains one of the most elusive entities in the universe. Scientists are on a relentless quest, using sophisticated detectors and innovative techniques to uncover this hidden mass. The discovery of dark matter would not only revolutionize our understanding of mass in space, but also shed light on the fundamental nature of the universe. As we delve deeper into the cosmos, we remain hopeful that the enigma of dark matter will one day be unraveled. Until then, the quest for the hidden mass continues. Why should we care about understanding mass in space? Well, let's dive into this fascinating subject. This understanding has many practical applications, especially when we talk about space travel and exploration. Imagine this, we're planning a trip to Mars. To ensure a successful journey, we need to understand the mass of the spacecraft, the astronauts, and even the supplies on board. This knowledge helps us calculate the amount of fuel required, the trajectory of the spacecraft, and even the impact of gravitational forces along the journey. In essence, understanding mass in space is the cornerstone of space travel, making missions like landing rovers on Mars or sending satellites into orbit possible. But the implications of understanding mass in space go beyond just practical applications. It also holds the key to solving some of the greatest mysteries of the universe. For instance, The concept of dark matter, which is believed to make up about 85% of the matter in the universe, is fundamentally tied to understanding mass in space. By studying how galaxies rotate and how light bends as it travels through space, scientists hypothesize the existence of this invisible yet massive component of our universe. Moreover, our understanding of mass in space is continually evolving, thanks to ongoing research and studies. Scientists are tirelessly working on experiments aboard the International Space Station, launching satellites to study distant galaxies, and using advanced telescopes to observe celestial phenomena. Each discovery brings us a step closer to a more comprehensive understanding of how mass behaves in the vast expanse of space. So why does understanding mass in space matter? Because it's a fundamental aspect of our universe, integral to both our practical endeavors in space and our quest to understand the cosmos. The more we understand about mass in space, the closer we get to unraveling the secrets of the cosmos. So let's keep exploring, keep questioning, and keep pushing the boundaries of our knowledge. Because in the vastness of space, every bit of mass matters. If you enjoyed this video, don't forget to like and subscribe. Your support helps us continue our journey of discovery, unraveling the mysteries of mass in space. Did you find this video informative? If so, hit that like button. Your likes show us that our content is helping you understand the complexities of our universe. And if you're fascinated by space, physics, and the enigma of mass, make sure to subscribe to our channel. We'll continue to bring you content that dives deep into these topics, expanding your knowledge and satisfying your curiosity. Subscribing also ensures you won't miss out on any of our upcoming videos. So, come along on this journey of discovery. Let's keep exploring, keep questioning, and keep pushing the boundaries of our understanding together. Thanks for watching, stay curious, and keep exploring the universe with us.